I'm Prep. Welcome to your next class of the mini mock test series. I hope everybody is doing very well, guys. And tell me who has joined the session. So, just like in our previous three sessions, we have discussed the question based on the common subjects, starting from a network theory, analog electronics. We discussed question based on the particular subjects like signal system, control system. So in the last 3 days, we have seen approximately 30 to 35 questions. So that will be help you a lot. Now, in today's class, we are going to see the question based on analog electronics and signal system. So this session is going to be a useful session. With the help of question, you are going to understand a few concepts also. Okay, so let's everybody join the session and then we will start. And everybody join the session and then we will start. So tell me who has joined the session as well as Bacho. Share the session among your friends and those students who are watching it recorded. I will kindly advise them come and watch the live session so that you can ask your doubts also. So let me introduce myself. My name is Shan Mudgal. I have a 7+ year of teaching experience. M.Tech gold medalist from NIT Allahabad, 7 times GATE qualified, and these are my area of expertise. And right now we are doing the question based on analog electronics and also the signal system. Before starting the session, let me give you one information that Rakesh sir is going to bring a very awesome session tomorrow on a topic of comprehensive 1-year plan to conquer GATE 2025. This session is going to be held on app and the timing will be 7:30 p.m. So, bachcho, enroll for this particular session. You are going to get a lot of knowledge ki how to prepare for your GATE examination or what's your study plan, what's your critical thinking about that. Also, bachcho, we have launched our scholarship test. This scholarship test will be on 26 November between 9 a.m. to 9 p.m. To register for this test and you are going to get up to 90% off on all our programs. Okay, so let's start our session. But tell me who has joined it. Okay, there's no one in the comment section, but students are live. So tell me who has joined the session. And this is the first question on your screen. This is the first question on your screen. So read the question carefully and give me the answer. Read the question carefully and give me the answer. In the circuit shown below, if the saturation output of the op-amp is 12.5 volt at power supply of plus minus 15, then the frequency of a square wave output is kilohertz, is dash kilohertz. The frequency of a square wave output is dash kilohertz. So first of all, observe this question carefully. First of all, if you are able to find out, then tell me which type of circuit is given here. Which type of a circuit is given, or you can tell me which feedback is given here. You can tell me which feedback is given here. Because this point is very, very important to understand. This point is very, very important to understand here. You have to identify the type of feedback. You have to identify the circuit here. Okay. So let's see who has solved the question. Who will solve the question? But also, batao, kaun aa gaya? Tell me in a comment section who has joined it. Let me see whether the session is going on all right or not. Let me check whether the session is going all right or not. So I guess session is going all right, but students are not replying. Okay, no problem, bachcho. If you want to be a ghost, then be a ghost. Okay, so let's see. So first of all, you can see this is a positive feedback network. This is a positive feedback network. Why, sir? Why this is a positive feedback network? Because in a circuit, we can see we have both positive and negative feedback. Bachcho, they have written clearly that op-amp output is saturates is 12.5 volt. Whenever the op-amp output saturate, it means the positive feedback dominates when they have given you two feedbacks. So here we have two feedbacks, negative and positive, but positive feedback dominates. That's why it's a positive feedback. Otherwise, output will have some another value also. It will not going to the saturate there. Next point, if you see, this is the circuit of a astable multivibrator. This is the circuit of a astable multivibrator. So how we can identify this thing? In case of multivibrators, there is no input signal. Good evening, Shivani. In case of multivibrator, there is no input signal. And in this question, you can see there is no input signal available here. So it means this is a multivibrator. Now, multivibrator are actually 3 types: bistable, astable, monostable. In case of astable, we use the capacitor. And in case of monostable, we use capacitor in parallel with diode. So in this way, you can identify the circuit. So this is the circuit of a astable multivibrator. Now after identification, you should remember the formula of a time period here. The formula of a time period here is 2 times of RC ln 1 plus beta divided by 1 minus beta. And bachcho, this formula is very, very important. For your gate examination, this formula is very, very important. The derivation of this formula will take some time. That's why I am telling you to remember this formula. Otherwise, in the derivation, you will, I can say, you can waste your approximately 5 to 6 minutes for this derivation. And the question is just 1 mark question. So that's why we need to remember this formula. In my classes, I always prefer the derivation, but in derivation, the derivations in which large amount of time will be taken, you can skip that derivation and just remember the formula. Okay, but yeah, you should understand the derivation also, because sometimes what happen in a 2 marks question, they will give you a random circuit. In that you need to start from a scratch. Okay, so derivation understanding is also important. So here, what is RC? Now RC is the resistor which comes in a path of a capacitor. So this is the RC. What is beta? Beta is actually the feedback factor. So here, if I say what is beta here, beta is actually a feedback voltage by V naught. Now using a voltage division rule, can I find out the ratio? Using a voltage division rule, I can say 47 divided by 47 plus 10. Yes or no? We just use the voltage division rule here. So it comes out to be 47 by 57. So this is a beta. Now put all the values in the formula. So time is equal to, time period is equal to 2 times of resistance, 10 kilo ohm and 0.10 kilo ohm and 0.01 into 10 raised to power minus 6 farad, multiply by ln 1 plus beta 1 minus beta. Okay, ln 1 plus 47 by 57 divided by 1 minus 47 by 57, like this. Now yes, we have to use the calculator. So we have to use the calculator here. Also you can do the derivation, or you can also do the calculation by yourself. Okay, so we have to use the calculator here, and also you can solve this question using a virtual calc you got. Okay, so try it. Tell me what will be the answer here. Multiply by 2, multiply by 0.01. So it comes out to be 0.046, and 4 is here minus 2 into 10 raised to power minus 2 seconds. If I am not wrong, it comes out to be this way. Yes or no? Into 2 into 0.01. Yes, correct. Now we need to find out a frequency. Frequency is 1 by time period. Frequency is 1 by time period. 1 divided by 0.046 into 10 raised to power minus 2. So it comes out to be how much? 21.73 into 10 raised to power, I can say 10 raised to power 2. 10 raised to power 2 hertz. Or I can say 217.3. Or we need to find out in kilohertz. Okay, we need to find out in kilohertz. We need to find out in a kilohertz. So it will be how much? Wait a sec. We need to find out in a kilohertz. So it will be 2.173 kilohertz. So this is the answer. 2.173 kilohertz. So this will be the answer. Okay, got it? So this formula of time period in case of astable multivibrator is very, very important, bacho. Okay, the derivation is also important, because if the question will change slightly, if I add a diode here or I can add one more branch here, the formula will change, but that question will come for 2 marks then. Next question. Again a good question. Again a good question. Try to solve this question. Try to solve this question. Op-amp is very, very important for your exam, bacho. Op-amp is very, very important both for EC and electrical. That's why our more focus will be on the op-amp today. We already solved the question of BJT, FET in our previous classes. Hai na? So today our more focus will be on op-amp. So try to solve this one. Consider the circuit shown below. The circuit will work as well. Let me write down one more option. Second order low pass filter. So we have 4 options here. The circuit will work as how? Second order high pass filter, second order band pass filter. Achha, low pass filter is already given. Let me add the second option, band stop. Band stop. Band stop filter. Okay. So try to solve this question. How you can solve this? How you can solve this? Think about it. Simple conceptual way or the shortcut way you can solve this question. In a shortcut way also you can solve this question. Think about it. If you know how to solve this question, you can give the answer in comment section. Virat said high pass filter. Okay. Why, Virat? Have you tried to solve it? Have you tried to solve it just by observing the circuit you said? Just by observing the circuit you said high pass filter. Try karo. Let me do one thing. Let's draw the circuit for omega tends to 0. For omega equal to 0. For omega equal to 0, capacitor will be open circuit. For omega equal to 0, capacitor will be open circuit, right? So if the capacitor will be opened here, if capacitor will be opened here, the circuit will be like this. If capacitor is open here, we can draw the circuit will be like this. The circuit will be like this. This will be the circuit here once the capacitor will be open. So this is the circuit. This is the circuit. So tell me, what is the output voltage? Will it be 0 or not equal to 0? We just need to identify whether the output voltage is 0 or not. In this case, here you can see the particular input is open. There is no output voltage. So V0 comes out to be 0 here. Here you can see the V0 comes out to be 0 here. Also, you can write this like this. You can also write this thing like this. Just for the clarification purpose, you can also write this like this. So here you can see clearly, bachcho, that the particular op-amp is separated from the circuit. What is the output voltage? It is going to be 0. Now let's talk about for omega tends to infinity. For omega tends to infinite. For omega tends to infinite, capacitor will be short circuit. Capacitor will be short circuit. So if the capacitor is short circuit, let's draw the diagram. If capacitor is short circuit, let's draw the diagram here. So if capacitor is short circuit, bache, then the diagram will be like this. Okay, let me check. Correct. Huh. So what will be the output voltage here? Let me put resistor values. It is R1, it is R2, it is R3. So what is the output voltage? You need to check 0 or not. Whether the output is 0 or not. You need to check only that particular case. So what is the output voltage here? Is it will 0 or not? The answer is it will be 0. It will also be 0. Think about it. How? It will also be 0 in case of a output voltage. Let me check one more thing. Why it is 0 here? Why it is 0 here? A very important point. Why it is 0 here? No one is interested. So the answer is band pass filter. Answer is band pass filter. Always remember, let me tell you, for omega equal to 0, omega equal to infinity. For the low pass filter, the output voltage is not equal to 0. Output voltage is equal to 0. For high pass filter, output voltage is equal to 0 at omega equal to 0 and not equal to 0 for infinity. Band pass filter, output voltage is equal to 0 in low frequency and it is also equal to 0 in high frequency. Finally, in case of band stop filter, output voltage is not equal to 0 at both low and high frequency. So this chart you need to use if you want to identify the filter. Only in case of identification of filter. So in this case, for omega 0 and infinity, we are getting a 0 output. So here the answer will be band pass filter. Here the answer will be band pass filter. Okay, next one. Again, this is a 2-mark question. This is a 2-mark question. Op-amp based. Because Virat, see very carefully. Here you can see output. This is the feedback path. This is also a feedback path. You can see This is also the feedback path you can see, and this feedback path is going here. So actually this voltage source is only giving the current here in this line. Means if you see about the voltage source, it can only going to provide a current to R1, R2 only. If you see the feedback path is actually 0. Feedback path is here also R3, and this is also connected to a feedback path. Okay, and you know, in case of inverting amplifier, this is the particular formula. If RF is 0, the answer will be 0. So basically there are two feedback paths. One is R3 and one this whole short circuit. So since there is a short circuit here, that's why it will be 0. Understood? Now try to solve this question. That's why I told you, observe the circuit carefully. How V0 is 0? Because see very carefully. Lokesh, see very carefully. See, I have two type of path, minus, plus. Okay. See very carefully. In one path, I have R3. In one path, I have R3. In another path, I have this. In another path, I have this. Okay. Now, because of this path, because of this particular branch, this R3 will be removed. This R3 will be removed. Now, what is the output voltage in terms of the inverting amplifier? RF by R1 multiplied by input voltage. RF actually 0, so it comes out to be 0 here. Yes or no? Right? Lokesh has deleted the comment. Beta comment bana, don't delete the comments. No worries. If you don't know the answer, if you have any doubt, you can ask it. Okay, don't worry about it. Okay, because when you ask your doubts, then only you can get to excel in your exam. Okay, so don't worry, you can ask any doubts. Okay, and also if don't delete comments so that other people can also know. Good, Lokesh, very well done. Now try to solve this question. Easy hai. It's question based on numerical rather than the critical thinking. So try to solve this question. Also, on our app, I'm also taking the free classes. Yesterday, I have taken the classes on the question based on the steady state analysis. Today, I will take class on a topic of network theorem, in which I'm discussing 5 questions that are in which you can cover the whole topic here. So you can also watch those classes. The timing for those classes is 6 p.m. So download our app and you can watch my classes over there also. It's free for all. But you have to be so much attentive while you are doing the revisions, because questions are very much important. So the output voltage V0 in the following circuit is same as the input, but the voltage is minus Vi. Why the minus Vi? Simple sa logic hai, inverting amplifier use ho raha hai. Because of an inverting amplifier, here we have a minus Vi. Then the value of R would be. So here I can say, by using a virtual ground concept, I can take this voltage as 0. Using a virtual ground concept, I can take this voltage as 0. This is I1. This is I2. I3. So on. This can be the IN. And here I can take IF. So using a KCL, I can write down I1 plus I2 plus IN is equal to IF. Okay. Now what is I1? I1 is Vi minus 0. I1 is Vi minus 0 divided by R. I2 is Vi minus 0 divided by 2R. I3 is Vi minus 0 divided by 4R. Plus so on. Vi minus 0 divided by NR. Vi minus 0 divided by NR. There will be IN here. Vi minus 0 divided by NR. Now what is IF here? 0 minus V0 divided by 2. IF here is 0 minus V0 divided by 2. Now, according to question, what is the output voltage? Output voltage is minus Vi. According to question, output voltage is minus Vi. Achha, one more thing. They have said that it is still infinite. Hai? So, since it is still infinite, na, so you cannot write down this here. Because it is mentioned that it is still infinite. Is equal to Vi divided by 2. So Vi se Vi cancel. I will left with this equation, that 1 by R plus 1 by 2R plus 1 by 4R plus till infinity is equal to how much? 1 by 2. Now what we can do here? Tell me, how we can solve this equation? Think about it. Can I use the formula of GP, geometric progression? Can I use the formula of infinity, the sum towards the infinity in GP? Yes or no? The same concept I'm going to use here. 1 by R divided by 1 minus 1 by 2 is equal to 1 by 2 here. You know? So it comes out to be 2 by R is equal to 1 by 2. From here, R comes out to be 4 ohm. So R comes out to be 4 ohm. So question was simple. Question was simple. Just the mathematical work is there. Sum of GP, absolutely correct. The question was simple. Just we have to do the mathematical work here. Nothing more than that. Yes, Surjit, that is also correct. That is also correct. If you want to use the concept of DAC, you can use the concept of DAC here also. If you know the concept of DAC, you can directly get this equation. You can directly get this equation. No need to go through all of these equations. Okay. So yes, that is also correct. But sometime in examination, the concept of DAC is not going to click in your mind. So you can solve this question like this also. Okay. So before moving further, let me give you one more information that we have already launched our All India mock test, which is open for all of you guys. Kindly register for it. Start giving test here. From this test, you are going to get to know how much you understand till now, how much you have prepared till now. In this test, you can compete with many aspirants all over India. So it will help you a lot to boost up your practice, and the questions are also the top notch here. So the particular link is open from 25th November to 1st December. So don't forget to register for it, and it's free for all of you. So try to give as many tests as you can. Next question. Again, a good conceptual question. I will say conceptual question. It is a good conceptual question. Okay. In this, the numerical part is less, but whole question based on the concept. So try to solve this question. Assume that N-channel MOSFET is ideal, not deal, ideal, with a threshold voltage of 1 volt. The voltage VAB is. We need to find out the voltage VAB. So let's see who will solve this question. Let's see who will solve this question. Again, 1 mark question hai. Whole question based on a concept only. The earlier question was of 2 marks, okay? But this one is a 1 mark question. Everybody try to solve it. And also, like the session, bacho. If you are liking this, so Surajit giving 0 volt, okay, good. Why? Why, Surajit? Why it's a 0 volt? Okay, from this particular criteria, first of all, I know that this will be a ground. One node will be a ground here. Can you find out what is VGS here? Can you find out what is VGS here? VGS is equal to gate voltage minus source voltage. Now here, see clearly. What is the gate voltage? Gate voltage is 2. Gate voltage is 2 and the source is grounded. So VGS comes out to be 2 volt. Now we know one condition here about the VDS. The VDS is need to compare with VGS minus VT. So if I'm able to find out VGS minus VT, what is VGS minus VT? 2 minus 1. Why 1? Because VT given is 1 volt. It comes out to be 1 volt. Now the condition is that if VDS, drain to source voltage, is more than this, the condition is that if VDS is more than VGS, then we can say the given MOSFET is in saturation region. MOSFET is in saturation region. This condition you know, yes or no? Simple condition. Now, if you see in this circuit very carefully, that voltage connected here is 10 volt. Now, we need to compare 10 with 1, or you can say the drop across will be very less. Means the drop can be 2 volt, 3 volt, 4 volt. The drop can be anything, but it will be very much higher than 1 volt. That's why from this conclusion, I can say the VDS will be very, very higher than VGS minus VT. VDS will be very, very higher. Very higher means it can be 9 volt, it can be 8 volt, it can be 2 volt. So what will happen? The complete MOSFET will go into a saturation. And what happens when the MOSFET is in saturation? You can replace it by a short circuit. When the MOSFET is in saturation, you can replace it by the short circuit. In linear or triode region, you can replace it by a resistor. But in case of saturation region, you can replace it by a short circuit. Since we have a short circuit here, VAB is equal to 0. Since we have a short circuit here, VAB equal to 0. So correct. Surajit has given a right answer. And also the explanation is correct. Correct. Absolutely correct. Okay, understood this concept? Understood? In case of saturation, you can replace the MOSFET by a short circuit. In case of triode region, you can replace it by a resistor. Now next question. Mathematical question. Mathematical question, and it's a 2-mark question. Okay, so these basics of MOSFETs are very important. From a MOSFET, there is a high chance for the electrical student that 1-mark question will come. So when the 1-mark question will come, they will ask you more conceptual question rather than the numerical question. For the EC, there is a high chance of 2 marks question. So they will ask you some numerical part or conceptual part together. So you have to study well about a MOSFET because it's a very important device for your exam. Next. For the given circuit, find R pi, R naught and GS. What is GS? GS is I naught by VS. Okay. And the MOSFET and BJT is given. Akanksha, sir, previous question samajh mein nahi aaya. Okay. Akanksha, tell me one thing. What is the meaning of saturation region? How does a device behave in a saturation region? That's why my point is, how does device behave in a saturation region? In a saturation region, the device behave like a short circuit because all of these devices like BJT you have, MOSFET you have, or the op-amp you have, or not op-amp, the diode you have, all of these devices are actually act like a switch. See very carefully. If you talk about any device, if you talk about any switch, this switch, you can talk about, this can be your diode, this can be your BJT, this can be your MOSFET. Okay, any device you choose, when these devices is in a saturation region, they will act like a short circuit. When these devices are in a cutoff region, it act like an open circuit. One important point you need to understand here. Okay, now next point. When you talk about the MOSFET, this is the condition for the saturation, that drain to source voltage must be more than VGS. Okay, so this condition are going to satisfy here. Why? Because the overdrive voltage or the VGS minus VT, minus VT here. Overdrive voltage or VGS minus VT is equal to 1 volt, and the drain voltage you are applying is 10 volt. So there will be a less drop across 1 kilo ohm. Drop can be 1 ohm, 2 ohm, 3 ohm. This can be less than 1 ohm, 2 ohm, 3 ohm. So if there is a less drop here, the complete voltage will come across the VDS, and that's why it's going into a saturation. So the MOSFET act like a switch here. Because of that, there will be a saturation, and this will be short circuit. If this will short circuit, the current from the source will be supplied from here only. The current from a source will supplied here only, and there will be no current here, 0. For a MOSFET, there is one more property. When it is in a linear region or in a triode region, then always remember it can replace by the resistor, by a resistive load. So if this condition is not satisfied here, then we will replace it by a resistor and then solve the question. Next, try karo this question. Acha question hai. 2 mark question hai. Try this question. Got it, Virat? Yes or no? Switching concept of MOSFET is important. Not only for the analog. If you are from electrical stream, then for the power electronics also. The switching concept is important. Next, in this circuit, you need to find out R pi. What is R pi? This R pi and R naught. You can find out using a DC analysis. Whereas if you talk about GS, this you have to find out using the AC analysis. Okay. Now what is the formula of R pi? R pi is equal to 1 plus beta RE. Or what is the formula of RE? RE is equal to thermal voltage divided by IE. IEQ means the DC Q point. The DC current we have at Q point, IEQ. What is the formula of R naught? R naught is equal to VT divided by ICQ. VT divided by ICQ, it is R naught. Okay. So let's draw the DC model here. Let's first draw the DC model here. So in case of DC, what will happen? The AC source which is connected here will be removed and the capacitor will be open circuit. The capacitor will be open circuit and AC source will be short. So the circuit will remain like this. For the DC analysis, the circuit will remain like this. Sorry, this is -5 here. -5 here, 2.54 kilo ohm. Now here we have 0.8 milliampere. Okay, fine. We have plus 5 volt. And here I have a resistor like this. Okay, so this is a base current, IBQ. This is the collector current, ICQ. And this is the IEQ. So one thing we can find out easily. What is IEQ? IEQ is 0.8 milliampere. What is ICQ? The simple formula. Beta divided by beta plus 1 multiplied by IEQ. So the beta is given. Actually, beta was given here. There's a misprinting in a question. There's a misprinting in a question. Beta is actually 60 here. It is given, okay? There's a misprinting in a question. Beta is 60 here. Beta is 60 here. And the early voltage should also given. No, early voltage aega. My fault. Correct, you're right. There will be an early voltage given. There is an early voltage given here. So there is a mistake in the question. Let me write down the values here. Early voltage is 50 volt. Early voltage is 50 volt. That is also correct. That is also correct. Okay, early voltage is here. Absolutely correct. Virat, well done, beta. So here. So let me solve this question. ICQ. 60 divided by 61 multiplied by 0.8 milliampere. So it will be how much? It will be around 0.8 only. It will be around 0.8 only. 60 divided by 60 divided by 61 multiplied by 0.8. So 0.78 we have. 0.78 milliampere we have. Okay. Now what is R pi? R pi is 1 plus beta. We have a thermal voltage. Thermal voltage divided by IEQ. So it comes out to be 61 multiplied by 26 millivolt divided by the 0.8. 26 millivolt divided by the 0.8. So tell me, what is the R pi here? 61 multiplied by 26. So it comes out to be 1.98 kilo ohm. What is R naught? R naught is early voltage divided by ICQ. So it is 50 volt divided by ICQ. ICQ is given 0.78. So it comes out to be 64 kilo ohm. 1 kilo ohm. Yes or no? Are you getting these values? Tell me, guys. Are you getting these values? Tell me. Are you getting these value or different value? R pi and R naught we got. R pi and R naught we got. Now the main point is how to find out the GS. For this we have to do the AC analysis. But first I am going to find out the GM also, transconductance. What is transconductance? It is equal to beta divided by R pi. This is the transconductance formula. So beta is 60, R pi is 1.98. 60 divided by 1.98. So it comes out to be 60 divided by 1.98. $30.3. It comes out to be 30.3 milliampere per volt. 30.3 milliampere per volt. This is the transconductance. Yes or no? Now we have to do the AC analysis. Now understand very carefully. When you do the AC analysis, you have to remove all the DC sources. You have to remove all the DC sources. See very carefully. When you're doing the AC analysis, you have to remove all the DC sources. So this source will be removed. Minus 5 volt will be removed. And this will convert into the R pi model. This will convert into a R pi model. Okay, so let's find out the R pi model here. So first of all, I'm converting into a R-pi model. So this is a transistor. This is the base here, R-pi. This is the ammeter here, which is grounded. Okay. Plus minus V pi. This is GM V pi. This is GM V pi. Okay. Now let's draw the circuit carefully. First, we have a source voltage and the capacitor will be short circuit. First, we have a source voltage, capacitor will be short circuit, and there is one more resistance here, which is equal to 24.8 kilo ohm, kilo ohm. This is the source voltage. Okay. Now here we have a GMV pi. Here we have a GMV pi, but the polarity you should mark very carefully. Minus plus. This is the GMV pi. Then if you see very carefully, you have a resistor of 2.54 kilo ohm and 4 kilo ohm. And there is one more resistor. Okay. We have a resistor here, one more, which is R0. And here we have one more resistor. And here we have one more resistor. This is 2.54 kilo ohm. Okay, this is 2.54 kilo ohm. It is 4 kilo ohm. And it is I0. Let me check one point. Okay, got it? There should be one bypass capacitor. So in the circuit you are saying there should be a one bypass capacitor. There should be one bypass capacitor here. That's correct. There should be one bypass capacitor here. Correct. Otherwise, it will be the floating. But if it is not given in a question, you can by default take it. Okay. Otherwise, for a floating ammeter, you cannot solve the question. For the floating ammeter, you cannot solve the question. It is a current source. Okay, my fault. It is a current source. Correct. It is a current source here. Correct. You are right. Okay. Ammeter to collector. Okay. This is the circuit here. Current source. Current source direction will be opposite. No, beta. Current source direction will not be opposite. You can see it is what type of transistor. It is the PNP transistor. It's a PNP transistor. So current is from ammeter to collector. That's why the current is from ammeter to collector. Got it? Yes or no? Surajit, got it this point? Now I need to find out the ratio of I0 and Vs. So how we can do this? Simple hai. Kaise? Can you find out the I0 using a voltage division rule? Current division rule. Can you find out I0 using a current division rule? Yes or no? Tell me, guys. Can you find out I0 using a current division rule? Kaise? I0 is equal to GMV pi R0 parallel to 2.54 divided by R0 parallel to 2.54 plus 4 kilo ohm. Yes or no? Any doubt in this particular equation of I0? Tell me, guys. Do you have any doubt in this particular equation of I0? Yes or no? Right? Now I have a I0 here. I0, what is V pi? If you see very carefully, V pi is nothing but equal to Vs. So we need to find out a ratio here. We need to find out ratio of I0 by Vs. So you can find out a ratio here. It will be GM R0 parallel to 2.54 divided by R0 parallel to 2.54 plus 4. This is the answer. After putting all the values, you can find out the answer. Here. GM R0 parallel to 2.54. Okay, got it? Yes or no? I'm not putting a values here. You can put the values. This is 30.3. You can put R0 is already 64.1 we have. Put all the values and you can find out the answer. Okay, any doubt here? Next one. Wait a sec. This is your homework question. It's a question based on signal system. This is your homework question. Take the screenshot. Provide the answer in a comment section. It is a very, very wonderful question you have. You have to use a multiple properties of Fourier transform and also one more property here. So take this question in your homework. Give the answer in the comment section after the class. Now next question. Back to analog. Next question. Next question. Okay, multiple, when you do the multiple question based on the analog topics, then you can excel your preparation, guys. Okay, try करो, solve करो. Try करो, solve करो इसको. The Zener diode question. The Zener diode question. The breakdown voltage of Zener diode shown in a figure below is a 4 volt. The current IZ through Zener diode is dash milliampere. Sir, your Telegram group link. Beta, search electrical by Ishan Mudgal. Search electrical by Ishan Mudgal. You can get my group. Search electrical by Ishan Mudgal. Okay, see very carefully how to solve this question. The breakdown voltage of Zener diode shown in figure below is 4 volt. Okay, that's the breakdown voltage. The current IZ through Zener diode is dash milliampere. So first of all, we have to check whether Zener diode is in breakdown region or not. Zener diode is reverse biased. Zener diode is reverse biased, that we are sure. But we need to sure whether it is in a breakdown region or not. For that, how you can check it? First, you need to assume that Zener diode is not in a breakdown region. First, you need to assume it is not in breakdown region. So for reverse bias condition, it will act like an open circuit. For a reverse bias condition, it will act like an open circuit. It is 2.3 kilo ohm. It is 2.2 kilo ohm. Now I need to find out this voltage, V. I need to find out this voltage. So V is equal to 12 multiplied by 2.3 divided by 2.3 plus 2.2. Simple voltage division rule. I hope अब आप इतने बड़े हो गए हो कि आपको पता है. Any discussion group? Yes, beta, you can search my group, electrical by Ishan Mudgal, and you can get the Telegram group. So we got 6.13. So we got here 6.13. 6.13 volt. We got here 6.13 volt. Now see very carefully. What is the Zener voltage? Zener voltage is 4 volt. Zener voltage is 4 volt. So Zener voltage is 4 volt, but the reverse voltage across it 6.13. So we can write down since V is more than the Zener voltage, the Zener diode is in breakdown region. Zener diode is in breakdown region. Now when the Zener diode is in breakdown region, you can replace it by a voltage source. You can replace it by a voltage source. So when you replace the Zener diode by a voltage source, it will be like this. When you replace a Zener diode by a voltage source, it will be like this. This is 12 volt. It is 4 volt. Okay. 0.1, 2.3, 2.2. 2.2, 0.1, 2.3. Okay, like this. We need to find out a Zener current. Now, this question can be solved easily. Yes or no? Simple KVL, KCL concept. We can solve this question easily. Do you want me to solve it further? So just solve कर लेते हैं. Answer आ जाएगा आपके पास. So V, let's suppose it is I1. Let's suppose it is I2. So we can solve it using the KCL method. I can write down V minus 12 divided by 2.2 plus V minus 4 divided by 0.1 plus V by 2.3 equal to 0. Now after solving this question, now after solving this equation, you can find out V. And after that, what is the IZ we need to find out? V minus 4 volt. We need to find out V minus 4 volt divided by 0.1 milliampere. That will be the answer. Okay. That calculation you can do it by yourself. 6.62 milliampere. Answer I don't remember. But I hope you have solved it like this. I hope you have solved it like this. The main point here is to identification whether the Zener diode is in breakdown region or not. And one more point, it is not a voltage regulator circuit. Remember, it is not a voltage regulator circuit because output voltage will change according to the current you have. Surajit, yes. Comment. Lokesh has again deleted the answer. No, sir, small mistake. Okay, fine, no problem. Now, before moving further, you can download our BYJU'S app, beta. On app, there are free classes going on every day by different faculties, by me, Sanjay sir, Rakesh sir. Today also, I am going to take a class here based on the network theorem. We will discuss 5 questions on network theorem at 6 p.m. So don't forget to download our app. Also, on an app, we have a feature of the live quiz that whenever we ask the question, you can give the answer. According to that, you can get a score and compete with the fellow aspirants there. So don't forget to download it, because also the free classes are going on. It will boost your preparation well. Next question. In the circuit shown below, a small signal parameter, the R0 in the amplifier given below is, R0 means output resistance. Okay, this is the output resistance, R out, not the small R0, not the small R0. It is R out. So try this question. Let me check one thing here. Okay, a small signal parameter R out for the amplifier given below is, okay, try karo. What is the R0 here, R out here? Although they have also given R out. Okay, same question. Try to solve this question. Easier. Just you make one particular AC diagram here, AC analysis here, then you can get the answer. Looking from a collector, looking from not a from an output terminal. You're looking from an output terminal. This is the output terminal. You're looking from output terminal. Now output is getting from where? You are getting the output from a collector. So you are looking for, at a collector side, you know, from an output terminal. That's why I have mentioned it is output resistance. That's why I have mentioned this is the output resistance. The only point in this question is to draw the AC model properly. If you draw the AC model properly, you can get the answer. Notice 2K parallel to 50K. Absolutely correct. Absolutely correct. Well done. When you draw the AC model here, how you can draw it? First of all, the capacitor is going to be short circuit and the VCC will be grounded. You can change this into any particular model. So let's draw the DC model here. So I have an input signal. VI. Okay. Capacitor is short circuit. Now see one point here. When this capacitor will be short circuit, then RF1 will be short circuit from this side, from the base side, but RF2 will be short circuited from the collector side, because one terminal is connected to the collector. So here I have to show the RF1 only. This is the base side. I have to show RF1 only. Then again, this is a model. This is actually a model here, R pi. You can draw any model. There is no necessary. You can draw any model you want. Because there is no use of model here. So this is going to be wait a sec. GMV pi. This is going to be a GMV pi. Now we are at collector side. So at collector side, we have one resistor. Which one? We have a resistor of RF2. So we have to put RF2 here. Also, we have one more resistor. Which one? We have a resistor RC. So when we have a resistor RC, this will be like this. Yes or no? The circuit will be like this. Now understand here. Whenever you are finding out output resistance, always remember it is equal to V0 by I0 when source voltage is 0. When the source voltage is 0. This point is important. Why? When the source voltage, or you can say the input voltage, एक ही बात है. When the input voltage is 0, the V pi is also 0. This is also 0. So it will be the open circuit here. Now if you observe from this side, you can only see two resistors, RF2 and RC. So RF2 parallel to RC. So RF2 is how much? It is 2 kilo, RF2 is 50 kilo ohm. So 50 parallel to 2. So how much you will get? 50 multiplied by 2 divide by 52. So 100 by 52 we will get. Let me check. 1.92 kilo ohm. 1.92 kilo ohm we will get. है ना? Simple question है. Just AC model you need to understand. अरे 1.92 आंसर तो आ नहीं रहा. we have done some mistake in a calculation. Let me check. We have a 50 parallel to 2 now. It comes out to be 1.92 kilo ohm, right? Let me check the values. It is a 50 kilo ohm because this 50 kilo ohm will go there. RC is also 2 kilo ohm. Also, we don't need to find out the R0 here because the small R0 value we cannot find out here because early voltage is not given. So I guess there is some mistake in options. You know? Rest of the methods we have done it correctly. Okay. There is some mistake in options. Okay. Next one. This is the last question. Options to do here. Options ko ignore karo. This is the last question. You have to find out the drain voltage here. You need to find out a drain voltage here. Solve this question carefully. We need to find out a drain voltage here. हाँ ये हो सकता है कि मिस प्रिंट हो या करेक्ट ये हो सकता है मिस प्रिंट हो ओके सो आवर टाइम इज गोइंग टू अप लेट्स सी just I will give you the idea about this question, how to solve this question. First of all, what are the ideas behind this question? Let me tell you that this is the MOSFET we have connected here. This is the BJT we have connected here. So one point you need to understand that actually this is also a mistake. Beta is 100. Okay. So one thing we can do here, the current inside the MOSFET is 0. Second point, I can find out the base voltage here. How? Using a voltage division rule, 15 multiplied by 2.5 divide by 7.5 plus 2.5. So we can find out a VB here. It will be how much? It will be 3.75 volt. So we will have a VB here. Simple si baat hai. We have a VB here, 3.75 volt. If I have a VB here, I can also find out a ammeter current, ammeter voltage. Kaise? We know VBE is equal to VB minus VE. So VE is going to be 3.75 minus 0.7. It will be 3.05 volt. Any doubt here? Any doubt till here? Now what will be the ammeter current? बच्चों? Ammeter current here will be ammeter voltage 3.05 divided by 1, 3.05 milliampere. Now one thing we can note here that I can find out collector current, and that collector current will be the drain current because from a gate there will be a zero current. So what will be the collector current here? It is equal to beta divided by beta plus 1 IE. So it is approximately equal to IE 3.05 milliampere because beta is 100, which is high. So we find out the IC here. We have a IC here, so drain current is also equal to IC. Finally, what is the drain voltage? It will be VDD minus IDRD. This is the drain voltage. So VDD is 15 volt. It is 2 kilo ohm. So 15 minus 2 multiplied by 3.05. So 6.1 we got 8.9 volt. We got 8.9 volt option B. We got 8.9 volt. Understood? Simple question hai. Just you need to see the question, the flow of current carefully. Once you understand the flow of current carefully, there is nothing left in this question. Okay, got it? So we will end our session here. I gave you one question of signal system in your homework. Try that question and give the answer in the comment section. So bye guys, take care. We will meet in our next class. Till then, अच्छे से पढ़ाई करो, app install कर लो, and the question, and in the app where I'm taking the session whole week, also the extra question is going to happen. So bye guys, take care. See you in next class.